Okay, here we go. We're going to continue that one last puzzle time. We're going to look at 7.8. And here we're looking for what do you get when you cross a computer with a freezer? So these polynomials that we're working with here are going to be polynomials that will probably need to be moved into probably more of an expanded form. We made it closer to grouping. So we're going to begin with our first one here. It says factor the polynomial. Remember, we're just trying to find, first of all, the GCF, which here is going to be 6. I know 6 can go into 6, 6, and 36. And we're going to take out the greatest common factor for my variables, which will be x cubed, which is now going to leave me with x squared plus x minus 6. Okay, now I've got this trinomial. Let's break this down. That has a leading coefficient of 1, so I just need two factors that multiply to negative 6. That means one's going to be positive, one's going to be negative. Well, wouldn't that just be 3 and 2? I'll make the 2 negative because I want the middle term to be a positive 1. So I'm going to keep the 6x to the third, and inside my binomials, I'm going to split up the x, so x and x. I'm going to have a positive 3, so plus 3, and a negative 2. Well, that's all it wanted us to do. It wanted us to factor. The next problem, though, says it wants us to solve. So we're actually going to find x. Well, when I look here, again, GCF first, but I don't have a GCF I can take out of everybody. I do know that I have 4 terms, so I have a polynomial, so I'm looking for grouping. I'm going to see, can I get a GCF out of the first 2 terms and then a GCF out of the second 2 terms in order to create a greatest common factor. So x to the third plus 2x squared. I can take an x squared out, and that will leave me with x plus 2. I'm going to look at my second set. I have negative 36 and negative 72. Now, I know that 36 will go into 72 twice. So I'm going to take out the negative 36. And when I do, that's going to leave me with x. Now, negative 72 divided by negative 36 will leave me with plus 2. And that works out pretty great, because now my common factor there of x plus 2, I'm going to write that first. And then I'm going to regroup and put the GCF that I took from the first and the GCF I took from the second together in their own binomial. So x squared minus 36 equals 0. Now this is one of those where you have to be careful. So you have x squared minus 36 here. That binomial has a difference, and it still has x squared in it, which means I have to check for a difference of squares. X and x makes x squared. Is there a number multiplied by itself that makes 36? Yeah, 6 does. So we're going to rewrite this. I'm going to keep the x plus 2. That is addition, so I don't have to check that one. But x squared minus 36 is the same as x plus 6 and x minus 6. Again, that is a difference of squares. There's the difference. X squared and 36 are both perfect squares. Now we just use what we've known before. Each one of these factors is going to be set equal to 0. So I have x plus 2 equals 0. I have x plus 6 equals 0. And I have x minus 6 equals 0. So that means that x equals negative 2. X can equal negative 6. And in this problem, x could equal positive 6. So if I was to write this as a solution set, I would say, well, that's negative 6, negative 2, and positive 6. I have 3 options here inside my braces. Up here on the right, the hint reminds you in number 14, you're going to have to set the equation equal to 0 before you can start factoring. And then we have our application, or our word problem. The volume of a box is 30 cubic inches. So we know the volume is, we know what the V stands for. Remember volume, I've got a box, so volume is going to be volume equals length times width times height. I know what the V is, it's 30. They've already told me that. The width of the box is 2 inches less than the length Okay, so I'm comparing the width to the length. All right, and the height is 3 inches less than the length. Find the length of the box. Well, really, this important part here is figuring out what to call everybody. So if you notice, everybody's being compared to the length. So let's call the length, we're going to call the L X. Now let's go back and compare. If I talk about the width of the box is 2 inches less than the length. So wouldn't that be X minus 2? 2 inches less? Now the height is also being compared to the length. The height is 3 inches less. Okay, so X minus 3 is my height. It's the length, subtract 3. It's 3 inches less. Now find the length of the box. Okay, so remember it's length times width times height, so that means that I can say, well, if I multiply all of this together, it should equal 30. Now remember, if we want to solve that it can't be 30, it has to be equal to 0. So we're going to begin by simplifying the left. I'm going to have to multiply. So I'm just going to multiply the x into the first binomial, say x squared minus 2x is my new binomial, and then I'm going to have x minus 3 still equals 30. We haven't changed that yet. And now I have two binomials, so we're going to FOIL. X squared times x is x cubed. X squared times negative 3 is negative 3x squared. Now we got to go back. Negative 2x times x is negative 2x squared. And negative 2x times negative 3, well, that is positive 6x. All of this still equals 30. I can simplify a little bit here, though. I have negative 3x squared and negative 2x squared. So that would be x cubed minus 5x squared plus 6x. Now, right here, I know that this 30 is on the wrong side. So I'm going to go ahead and subtract it over and rewrite this. Minus 30 is going to equal 0. Well, if you look here, I have a polynomial, 4. I look for a GCF, and I don't have one. That means I'm going to try to regroup them. I'm going to say if I put the first two together, can I take something out? And I can. I can take out x squared, which would leave me with x minus 5. And then I'm going to look at my second two numbers. I have a positive 6x and a negative 30. Well, I'm going to take out the 6. If I take out the 6, does that leave me with x minus 5? It does. So let's rewrite this. Let's go ahead and just move this up here and rewrite this. That means I'm going to have x minus 5. That's my common one, right? I had both of them have an x minus 5. And then the second binomial is going to be x squared. We took out a positive 6, so plus 6. And this still equals 0. All right. I look for a difference of squares here because we had a problem like that a second ago, but look, that's addition. So that is not a difference of squares. There's nothing I can do with this binomial. But I can set them both equal to 0. So in my first one, I will have x equals 5. I'm going to add 5 to both sides. Now here, I would have x squared equals negative 6, right? And I would need to take the square root of negative 6, but here's the problem. It's negative. Distance cannot be negative. Just like time cannot be negative, distance cannot be negative. So because this is a negative, I cannot use this number. But I can say that x could absolutely be 5. And that's what it wanted to know, the length, right? And we define the length as x. So I could absolutely say that the length of this box is 5, equals 5. And I could go back and double check that. I could plug that in and make sure. Using my original equation up here, I could say, does 5 times 5 minus 2 times 5 minus 3, will that equal 30? Well, let's just simplify. Does 5 times, well, 5 minus 2 is 3, and 5 minus 3 is 2. Does that equal 30? Well, 5 times 3 is 15, and 15 times 2 is 30. So I can even prove that that is true. The length is 5, and what is it? In measurement, that is in inches. So I could say the length is 5 inches.